Dear fellow lecturers and friends, we are Group 2 and we will be sharing our experience on how our water filtration system went. Our group consists of Yanis, Narelle, Valerie, and Samuel. We hope that you will enjoy our video. Let's begin. For our filtration system, we didn't bring any extra materials and used what was provided in the lab, such as towel for housekeeping, half a water bottle, a box containing one piece of cotton pad, tea bag, soup stock bag, 4 rubber bands, and 2 small nets, 100 gram of 3 to 6 mm size gravel, 100 gram of 1 to 3 mm size gravel, 200 gram of fine sand. We started off by layering the base of half the bottle with one cotton pad and sealing it with tea bag to act as a filter and securing it with a rubber band. Next, we packed the individual gravel and in nets so that it can be repurposed after this experiment. As the sand is finer, we use a tea bag to secure it as the pore size is smaller. We then rinse them to ensure that there are no other contaminants in our gravel and sand which will affect our experiment.
We then dried the respective sand bags and gravel bags before placing them in the bottle.
After which, we layer them from finest at the bottom to the coarser gravel at the top.
So this is what our water filtration system looks like. In summary, this is the design of our water filtration system. We have 3 to 6 mm gravel at the top, 1 to 3 mm gravel in the middle, and very fine sand at the bottom.
Next, we will be moving on to the water filtration process. When we first filter the water, we noticed that there is a drastic change in color. However, our water was still cloudy, hence we decided to run the filtration system with tap water after each round of filtration.
After 10 rounds of filtering the pond water, followed by washing the filtration system with tap water, our filtrate collected was much clearer compared to the initial water given. After filtering our water, we then tested parameters such as color, turbidity, conductivity, pH, and alkalinity. Firstly, we tested the color of our filtrate.
To obtain color, first we reset the parameters of the water meter to 0 and filled the tube to the line, after which we clean the tube with clean wipe and begin measuring the water to obtain the following results. Next, we move on to testing the turbidity of the water by placing it into the turbidity meter and cap it securely and start the calibration. Next, we tested the conductivity by submerging a conductivity probe in the water to obtain the values. To test the alkalinity of the water, we use a water meter by resetting the parameters on the machine and adding the solution used for testing alkalinity into the water to obtain our following results. Lastly, to test out the pH, we dip a pH meter to check the pH levels of our filtered water. We did the same steps for the original pond water to obtain the following parameters for the original pond water.
This slide shows a summary of the tested parameters for the original pond water as well as our filtered water.
Next, I'll be passing the time to Yanis to share more about the reasons for our given data.
Thank you, Valerie. I'll be going through the possible reasons for the tested parameters observed for our filtered water. For the color of the filtered water, the result obtained is 176 Hazen from 500 Hazen, which is still too high when compared with the WHO standard, which is less than 5 Hazen. There are a plethora of factors that affect the color of the water. For instance, the presence of planktonic algae, minerals, nutrients, and dissolved organic matter in the pond water sample are some reasons for the coloration of the water. Our filtration system was only capable of removing suspended solid particles or organic matter affecting the color of the water, and not the dissolved compounds that affect the color of the water. Hence, when compared with the ionized water, which has a value of 0 Hazen, our filtered pond water has a much higher value since there is no further treatment to remove the dissolved compounds that affect the color with Hazen value. As for the turbidity of the filtered water, it was visibly still cloudy, even though 10 times of filtration had been done. The turbidity value decreased from 214 NTU to 27 NTU. Reasons for the decrease in the turbidity value could be due to filtering most of the suspended particles out of the pond water. Hence, this would increase the dispersion of light throughout the water, thus increasing the clarity of the water. However, Not all the suspended particles are removed by the filter layers in our filtration system because the size of these particles might be too small to be filtered out by our filter layers we use, resulting in the collection of our filtrate with a turbidity value of 27 NTU, which does not meet the WHO guidelines of 0.05 to 0.45 NTU. Next, I'll pass the time to Samuel.
For the conductivity of our filtered water, the conductivity value decreased from 1080 microsiemens per centimeter to 200 microsiemens per centimeter. The reason for this could be due to the dissolved ions in the pond water to be trapped in the tiny pores of the very fine sand during the first filtration run. Thus, this causes the sand to be saturated with all the pond water containing dissolved ions. As a result, the filtrate obtained has a lower concentration of ions present, thus conductivity decreases. Another reason could be due to diluting the sample with tap water after washing the filter layers with tap water. After the first filtration run, the sand filter trapped pond water with dissolved ions in the tiny pores between the sand particles. We then wash the sand filter by running it with tap water. This could result in the tap water containing little to none dissolved ions to replace the pond water containing the dissolved ions trapped in the tiny pores between the sand particles, thus washing the trapped pond water away. By doing this 10 times, it overall resulted in the dilution of the pond water with tap water, and thus a lower concentration of dissolved ions found in the filtrate at the end, leading to a decrease in conductivity value. For the alkalinity of our filtered water, the alkalinity value decreased from 500 mg per liter to 34 mg per liter. The reason for this is similar to the reasons for the decrease in conductivity. This is because the pond water containing ions causing alkalinity, such as bicarbonate and carbonate, was trapped in the tiny pores between the fine sand particles during the first filtration run. Thus, this caused the sand to be saturated with all the pond water containing the ions causing the alkalinity. As a result, the filtrate obtained has a lower concentration of alkalinity causing ions present. Thus, alkalinity decreased. The other reason could be due to dilution of tap water after washing the filtrate layers with tap water, which has the same principles as the reason conductivity decreased. Finally, for the pH of our filtered water, it decreased from 8 to 6. The main reason for the decrease is because alkalinity decreases, thus lesser concentration of alkalinity causing ions present in the filtered water. Hence, higher concentration of H+ ions and thus pH decreases. However, a pH of 6 does not fall within the WHO guidelines. In summary, our results obtained unfortunately do not meet the requirements of WHO standards, which can be observed from this slide above. Now, I'll be passing my time to Narelle, who will be talking about how we can improve in the efficiency of the filtration system, as well as improving the effectiveness of our filtration system to obtain filtered water that can meet the WHO standards.
Thank you, Samuel. Now, I'll discuss the improvements that can be made to better our filtration setup. Our filtration method was rather inefficient. This is because after every filtration, we would then have to clean the filter layers with tap water to remove all the contaminants collected in the filter layers. As a result, this took up most of our time and reduced the number of times we could filter the water, thus making this an inefficient method. Hence, in order to improve this, we could prepare multiple filter layers at hand before beginning the filtration process. For instance, we can prepare 10 tea bags containing very fine sand instead of just preparing 1 tea bag containing very fine sand. Thus, after every filtration run, we can immediately remove the used filter layers and add our new filter layers. By doing so, we can significantly improve the turnover time, as we no longer need to spend our precious time cleaning the filter layers. Our filtration system was relatively effective as the result color of the water had improved drastically at the end of the experiment. However, it still remained slightly cloudy as there were still contaminants of extremely small size that were able to pass through the sand layer and enter into the collected filtered water, thus the slight turbidity present. Hence, to improve the effectiveness of our filtration system, our group has come up with 3 solutions. For the dissolved or colloidal contaminants, they can be removed by passing over a layer of powdered activated charcoal, which is capable of absorbing a large variety of organic molecules onto its surface. The activated charcoal should also be finely granulated and in this case, powdered, so as to increase its surface area of contact with the water, therefore absorbing a larger amount of organic matter and clarifying the pond water. Activated charcoal is an extremely versatile and a highly effective water treatment medium, and it can also improve the taste, odor, and color of the water. The activated charcoal filter should be the very last layer that the water comes into contact with. The water should go through the sand layers first, so as to remove any larger impurities that may clog up the activated charcoal filter faster, so as to prolong and protect this carbon filter. Secondly, the use of 3 to 6 mm and 1 to 3 mm gravel was not needed, as there were no particulate matter of that size present in the pond water. We can instead replace these layers with more sand, such as silica sand, which will trap the small pathogens and suspended solids that are in the water. Providing a thicker sand layer will also ensure a higher removal efficiency of the impurities, thus improving the water quality. Last but not least, we can boil the filtered water so as to ensure it's safe for consumption. At 100 degrees Celsius, most pathogenic organisms, such as bacteria and viruses that cause diseases, are killed, making the water safe to drink. However, boiling does not remove toxic chemicals, such as lead and fluoride. For the effective removal of toxic substances, the water must go through appropriate processes, such as anion exchange resins or reverse osmosis. In conclusion, the filtered water we obtained does not meet the WHO or PUB standards under Part 4, analyzing our data. Much improvements can be done to our setup, such as by using activated charcoal, replacing the gravel with sand, and by boiling. We have come to the end of our presentation. Thank you!